Okay, I need to introduce you guys to Chapter 9, which the very first section is circles. Okay, circles is the first conic that we're going to look at. Conics, this comes from the word cone. When you slice a cone with a plane, going back to geometry, a plane, depending on how you slice the cone, you'll get different shapes. The first shape that you get is a circle, okay? The equation for a circle is x squared plus y squared equals r squared, where r is the radius of the circle. If you don't remember what a circle is the official definition is the locus of all points which are equidistant from a point. That's a fancy way of saying that if you have a point right here, P, and some radius, every point on this circle is the radius length away from P. Okay, and that's what a circle is. This particular equation right here, x squared plus y squared equals r squared, this is actually a circle centered at the origin. Okay, and by origin I mean 0, 0. So when you graph it, the center of the circle would be right there at 0, 0. So let's look at an example. So something like x squared plus y squared equals, say, 9. Okay, this is saying you have a circle centered at the origin with a radius of 3. Okay, so this is 3, 3, 3, 3. Okay, now if the circle isn't at the origin, things start to happen. It starts to shift. And I'll show you what the shift looks like. Okay, you might see equations of circles that look like this. This is still a circle because this is some, say, big X squared plus some big Y squared equals some radius squared. Okay, but instead of being centered at the origin, these plus 2 and this minus 3 here, it shifts things, okay? X deals with a horizontal shift, and y deals with the vertical shift. Okay, and the shift is always in the this number, this quantity, right? But in the opposite direction. So if this is x plus 2, the center of this circle is at negative 2, comma, and if this is minus 3 right here, the center of the circle is going to be at plus 3. You might be asked, what's the radius of this circle? Well, since r squared equals 16, r must equal 4. Okay, we can try another one. Maybe we'll have something like x squared plus y minus 10 squared equals, oh, I don't know, 225. Something like that. So you'll be asked, where's the center of the circle? Well, the center of the circle is at, well, there's no shift on the x, so 0. And then opposite of this number, so a shift of 10 up. What's the radius? 225 is, oh god, 15 squared, I think. So the radius would be 15. Okay, this is how the shift applies to this equation. Okay, so these conics typically have sometime a chain of polynomial that'll look like this. It's never really presented to you in the fashion that you want it to be, so you kind of have to make it that way. I put all the X stuff in blue and all the Y stuff in orange and then all the random stuff in black to show you what's going on here. The first thing you want to do is organize this. So I'm going to put all the blue together, x squared plus 12x. And I'm going to leave a blank there. Next I'm going to have plus y squared minus 2y plus some blank. And I'm going to move this 21 over to the other side. The reason I'm leaving these two blanks is because we have to do something that we haven't done in a while called completing the square. Okay, the way we complete the square is we take the b term. Okay, the b term, this is ax squared plus bx plus c. We're going to take the b term, so 12. We're going to divide by 2, and then we're going to square the entire thing. Comp the square. Okay, this will give us 6 squared or 36. We're going to take this number and we're going to add it to both sides. So we're going to add 36 here and we're going to add 36 over here. Next, we're going to have to complete the square with our y over here. So we're going to take negative 2, going to divide by 2, and square the whole thing. This gives us negative 1 squared, or positive 1. So we're going to add 1 to both sides. Once we've done that, what we can do is we can rewrite this as a binomial. Okay, or essentially what we're saying is we're going to factor this. Okay, when we factor this, we get x plus 6 squared plus what happens when you factor this over here. You get y minus 1 squared. And then this all equals, if we do all the addition over here, this is all going to equal 16. Okay? Once we're here, we're in the equation of a circle. So we can start to answer certain questions, such as, well, where's the center of this circle? It's going to be at the opposite of this as the x-coordinate, and then the opposite of this as the y-coordinate. And then what's the radius going to be? Well, the radius is going to be the square root of this number over here. So the radius would be 4. Okay, so this is how these problems are going to be presented. You're going to have to take this, and you're going to have to complete the square. So this is a good review for the final, because we're going to be completing the square. Put it into a circular equation, and then answer certain things about the circle. You might be asked to graph it too, but I'm not going to take the time to show you how to graph a circle. I'm going to let you guys play with that. Okay, other problems you might see in this section, besides the completing the square, is sometimes they'll say, hey, make the equation of a circle that's centered at 7, 5, and contains this point of 3, negative 2. Making the center part, well, that's pretty easy. All we're going to do is say, let's see, I need the opposite of 7. So I'm going to say x minus 7 squared plus. And this plus is really important. If this isn't a plus in the middle, it's not a circle. Okay, it has to be plus. And then the next thing is going to be y minus 5 squared. And this equals r squared. Okay, so we need to find r. Well, if we look at this, we need to understand that the straight line from P to C, okay, this has to be our radius. Okay, well, to find this radius, we're going to use an old friend from geometry. And now that I'm drawing this picture, you might remember what it is, okay? We're going to want to use our friend Pythagorean theorem, which says if we have a triangle, or a right triangle, okay, where A, B, and C, it's true that A squared plus B squared equals C squared. So what we're going to do here is we're going to say that 1, 2, 3, 4. This is a 4 by 1, 2, 3, 4, 5, 6, 7. We're going to say that 4 squared plus 7 squared equals r squared. And we're going to solve for r now. So 4 squared is 16. 7 squared is 49 equals r squared. Let's see if we add this up now. This is going to give us 65 equals r squared. Now, r squared is what's going to go up in the equation. So we can erase this and put 65. Okay? But then here's the tricky question, and I'm going to ask this tomorrow, is what actually is the radius of this equation? Okay? I know we solved for r squared, but I want to know what is the actual radius. Okay? So if there's any questions or comments on this, please let me know, and we'll work on some of these circle equations tomorrow.